So last time we did composite functions, today we're going to do inverse functions. I'm going to write all of our information that we need to know about our inverse functions here. So what inverse functions do is they undo each other. And you can say cancel each other out or cancels out. There's nothing necessarily wrong with that. I feel like undo is more descriptive though, because a function is a process. It's like doing something. So one function does something and the inverse function undoes it. So you get right back where you started. Does this make sense? Okay. I always bring up like socks and shoes. Like you take off your shoes, you take off your socks, you put on your socks, you put on your shoes. Okay, they undo each other. So the way you find an inverse is you're going to switch x and y. So wherever x is, you put y. Wherever y is, you put x. That's like the process for how you do this. And so if you're switching x and y, you're switching the input and the output. And so the domain and range are reversed. And that's actually going to be next time's lesson. Today, we're going to just focus on like finding an inverse. Next time, we're going to start talking about the domain and range. But in a nutshell, that's next time's lesson. You take the domain and range and you switch them. Like in a 2-second lesson, that's what you do. You're just reversing them. How do you tell if two functions are inverses? Well, if they're going to undo each other, you'll end up right back where you started. So f of g equals g of f, you would find those two composites, and they should both equal just x. Literally everything will undo each other, or if you want to say cancels out, everything will cancel out, and you would just end up with x. Everything else will go away. So you end up right back where you started. And if you're looking at them visually, because I know you can see some grids on here when we graph them, they reflect over the line y equals x. So let's real quick review what y equals x looks like, because you have to be able to tell if they're inverses visually too, like just look at it and see if they're inverses. So let me just off to the side here, graph the line y equals x. If we're thinking like y equals mx plus b, do you remember back from algebra 1, y equals mx? Good, thank you, heads nodding. What's in front of the x? What? So slope is 1, and if it's like 1x like plus b, it's plus nothing, so what's b? 0. So you would start at the origin and do a slope of 1. So this is what your line y equals x looks like. And inverses reflect over that line. So like visually, because when you get down to number 3 and 4 here, we're going to graph them, and like visually you'll be able to see that. All right, here we go. You'll have to let me know if this is familiar from last year. This lesson is actually nothing new this year. Like this is all stuff you did last year, so you'll have to let me know. Are they inverses, yes or no? And I give you credit for showing all your work, so you're going to have to show all the work. We're going to find f of g, and we're going to find g of f, hopefully just like you did on your quiz. If they both come out to just x, the answer is yes. If they come out to anything else on God's green earth, then the answer is no. Okay, so if they just equal x, it's a yes. Anything else in the world, it's a no. So for this one, what gets plugged into what? G gets plugged into F. And again, you have to label these for me. That's a common mistake on the test, is people will do all the work perfectly, but I have to take off like half a point because I don't know which one's which. So you have to label them for me. So G gets plugged into F. All of this is going to get plugged in for X over there. So it'll be 1/3 times all of that, and then a +2 at the end. Now don't try to force this to come out to anything. We're just going to see what happens. What would we do with the 1/3 that's there? Distribute that. So 1/3 times 3 is just 1x. 1/3 times -2. Well, first of all, it'll be negative. What's 1/3 times 2? Yeah, 2/3. Fun with fractions here, right? 1/3 of 2? 2/3? What would be 1/3 of 7? 7/3? Okay, don't overcomplicate it. It's just thirds. Now it's +2, but again, we need a common denominator. So you need it to be thirds. So $1,000,000 question. How many thirds is a whole 2? 6/3. Good. And then you can put those together. So it'll be x, something with thirds. -2 + 6 be 4/3. So here's the big takeaway though. Did it come out to just x? No. So we already know the answer is no. These are not inverses. I'm gonna have to do a pep talk here because what everybody always says, we already know the answer is no. How come we have to do the other one? Here's why. On the test, I can't tell you ahead of time if it's a yes or no. So I make them both worth credit. So it's worth points to do the other one. So you just have to, okay? Okay, thank you for not giving me a hard time. Just be like, hey, I'm gonna get points for doing this. This time F gets plugged into G. So now this all gets plugged in over here. We won't get a fraction in this one, okay? So it's going to be 3 times all of this and then minus 2. So now what? Distribute the 3. What's that going to give us? X plus 6 minus 2. So X plus 4. And so the answer is no. They are not inverses. They did not undo each other completely and get you right back to X where you started. And you guys know me at this point. If I made that one be a no, what do you think I did for this? So that you can see how it works both ways. Okay, but you get credit on the test for doing it, so you just have to do the work. It's like you get credit for work. Kind of like working a job, like you show up and do your shift. That's what earns you the money. Like you just have to do the work to get the points. And again, label them because I have to know which one you meant was which. So F of G, G gets plugged into F. So this 4x plus 9 is going to get plugged in right there. So it'll be 4x plus 9 minus 9 over 4. Here's the other mistake I get a lot on the test. And it's not necessarily a mistake, but it's like a I can't read with you kind of thing. People see that it's all going to cancel and they'll just write equals X. The order in which it cancels is important. That's like understanding algebraically what's going on. So you have to cancel them in the correct order. And if you just put slashes through everything, I can't tell. What cancels first, the 4s or the 9s? Okay, so you have to write me the middle step because my telepathy is broken. And if you just put slashes through everything, I can't tell what order you did it in. So cancel the 9s, one thing at a time. What's left? Yeah, you have to write me that middle step so I can see it. And then the 4s cancel and you just get X. So the order in which it happens is important. Like mathematically, that's showing you understand the algebra. It doesn't seem like anyone's giving me a hard time about that though, so I'll lay off. All right, here F gets plugged into G. So this entire fraction is going to get plugged in over here. So that will give us 4 times this whole thing and then plus 9. Everything's going to cancel in the opposite order this time. So what cancels first? Yeah, the 4s. Like up here, the 9s canceled first. This time the 4s cancel. And you have to write me the middle step so I can see that. What's left? Well, the 4 canceled, so that's gone. Yeah, X minus 9 plus 9, which feels silly to write. But again, if you just slash it all out, I don't know what order you did it in. And then, yes, that will just equal X. And so we're going to say, yes, they're inverses. Yay. All right, now we're going to find inverses and then graph them. Here's my suggestion. Let's do the graph first because the graphing is what always scares people. So let's graph first, okay? I'm going to make my original function be pink. Pick a color if you have 2 different colored pens, or if not, you don't have to. But if you are going to color code, pick your first color. What is this graph going to look like? A line, right? Like everyone's just sort of doing this. Okay, so y equals mx plus b. We're going to start where? Yeah, -2. Good. Okay, I'm waking you up. Start there. -2. Slope is 3. So you're going to go up 3 over 1. And there's your line. Now you can actually graph the inverse without finding the inverse, which is what I recommend you do because the graphing is what scares everybody. Do that first and get it out of the way. Like this algebra goes really well. Everybody's like usually fine with that. It's the graphing that's like scary. You can get your inverse graph without actually finding the inverse. All you're going to do is take all these points and reverse them. Take all these points and reverse them. You ready? 1, 1. If you reverse that, it would be, well, just 1, 1, right? If you take 1, 1 and flip it around, it's still 1, 1. Okay, so we have that point. That's where they're going to intersect. What is this point? 2, 4? If you reverse that, what do you get? 4, 2. So plot 4, 2. And then what is this one? 3, 7. So if you reverse that, what do you get? 7, 3. And does your slope instinct kick in at a certain point? Like after you get 2 or 3 points, can you see it and just like keep the pattern going? The slope of the pink line was 3. What's the slope of what this is green? I'm trying to make green here. What's the slope of the green line? Do you see that? One's 3 and one's 1/3. Oh my gosh, that's crazy, right? Absolutely wild. And what I want you to get out of this is, doing this visually, they reflect over y equals x. If you dot in that line, y equals x, can you see that they're reflecting? It's kind of a thing I can't force you to see. I can't go up to you and shake you and be like, do you see it? You know, but like, do you see it? It reflects, look kind of like butterfly wings or whatever. So that's my 2 cents. Do the graph first. It calms everybody down. It's like, hey, I did the hardest part. Usually the graph is the hardest part for everybody. Then go back and do like these algebra steps. Find the inverse. How do we find an inverse? Switch x and y. Would sure help a lot if there was a y in the problem. Would sure help a lot if there was a y in the problem, wouldn't it, guys? F of x is y. Scribble out the f of x and call that y. And then switch x and y. Here's the pep talk. Don't move anything else. Switch the x and the y and leave everything else where it is. The equal sign, all the numbers, leave them where they are. This will give you x equals 3y minus 2. And then you solve it for y. So welcome back to algebra class. What would you do to both sides? Add 2. And then divide by 3. X plus 2 over 3. Now, if on your test you write equals y, 100% full credit. For heaven's sake, you got the right answer. But I'll be happier if you write inverse. Does anyone remember what an inverse notation is? I'm going to tell you if you've all forgotten, but what means inverse? F of x is function. Do you remember how we changed that to make it mean inverse function? Yeah, you put a little negative in there, and that's your notation that means it. Oh, I heard somebody go, oh, do you remember that from last year? Or is this like familiar, sort of? Try to remember to put that. That's what means inverse. That is the notation that means inverse. It's f of x with a little -1 in it. Let's try it again. I would do the graph first. I'm going to make this original one be pink. I know the colors don't show up real great, but you can try. What is this graph going to look like? Hint, it's not a line. A squiggly, like a wiggle, moved. Perfect. Okay, go down 4, put a point. You guys are all awake. You're just quiet. That's good. I can work with that. And then I want some more points, like at least a couple more. So we're here at 0. Let's try plugging in 1. You ready? 1 cubed. 1, very good. Minus 4 is -3. So we get 1 -3. And then look, work smarter, not harder. If this is the center and I know that, and I know it's going to wiggle, it's going to do something like this. Where can I put another point? Like if this is the middle and I have a point there. Yeah, like on the other side of it. And it's going to do something like this. That's what knowing your parent functions and the transformations is so helpful. Because if you just know what the shape is, you don't really have to do a whole lot more work. And you can graph the inverse without even finding the inverse. Just take those points and switch them, all right? So if we have 0, -4, what point's going to be on the inverse? -4, 0. Yeah, you don't want to change the positives and negatives. Like just keep them where they are. If you have 0, -4, when you switch that, it's -4, 0. Like just reverse them. You're not negating them or anything. And then we have 1, -3, so that'll give us -3, 1. And then what's that last one? -1, -5, so -5, -1. And it's going to be a sideways wiggly. And the big takeaway there, I want you to see that it reflects over this line y equals x. And again, that's not something I can like force you to see, but like, do you see it? It's a way you can check your work, because if it doesn't reflect and it looks all wonky, then you can be like, hey, I made a mistake somewhere. Also, foreshadowing. If this is cubed, when we find the inverse, what is the inverse going to have in it? A cube root, that like sideways wiggly? All right. Switch x and y. Would sure help a lot if there was a y in the problem, right? Scribble out f of x, that's what's y. Everything else stays put, just switch the x and the y. X equals y cubed minus 4. And then you want to get y by itself. So what are we going to do? Yeah. Plus 4. Again, these are the steps that usually everybody's kind of okay with. This like sort of goes well. And then to get rid of the cube root. So cube root x plus 4. And again, if you forget on the test and put y, I'm not going to mark it wrong, like full credit, but try to remember that that means inverse, because you should know that. And plus it's just f of x with a little -1 in it. So for heaven's sake, it's not like a really huge thing. Take one more like 2-minute break. So for all of these, we're doing what we did on the front. I'm just not going to make you draw a graph. So find the inverse. So we are going to switch x and y for all of them. It's the same directions for all of them. And then do all of the undoing steps to get y by itself. So if we switch x and y, this will be x equals 2 over y minus 1. And I made these ones in the back a little bit more complicated with the algebra. You have to get y by itself, but where's y? It's in the denominator. So the first thing you have to do is get it out of the denominator. Any thoughts or suggestions? And I would maybe give this a hug. Good. You're going to multiply the y minus 1 to the other side. So if I multiply this over here, it will give me x times y minus 1 equals 2. That doesn't look a whole ton better, but at least it's not a fraction. Small victories. All right, now you're still trying to unbury y. You still want y alone, like this is your goal. So what would you do next? Divide by x. Now, if you were thinking distribute x, you're not wrong, and you can do it that way too. You'll end up with a correct answer, but I would just divide both sides by x to get rid of that. I think that'll be a little bit easier. But again, if you distributed the x and then solved from there, that's fine too. That's like personal preference at that point. And then what's your last step? Plus 1. And instead of y, try to remember to put inverse. It'll be 2 over x plus 1. It's basically just a really big, huge review of all your algebra solving skills, like solving equations. Let's try it again. Scribble out f of x, call it y, and then switch x and y. Everything else stays put. So it'll be x equals y plus 2 cubed over 5. And you're just trying to undo everything that's there. It's like the definition of what an inverse is. Right? And getting it in the right order is the important part. So what would you do to both sides first? Yeah, multiply by 5. So 5x is going to equal like all the rest of that. Sometimes I think these are kind of fun. It's sort of like doing a puzzle. You're just undoing all the steps that are there. All right, and then what next? Cube root, good. Cube root 5x equals y plus 2. And then minus 2. It doesn't matter where you write it, but do you remember when we were solving and we had like those plus and minus square roots? Do you remember those? No, so okay. Thank you, one person. So when you subtract over the 2, I would put it in front. Again, if you don't, it's still correct. But do you remember why we didn't put them at the end, or like what was the kind of reasoning behind that? Yeah, like confused that it'll be like underneath the roots. That's why we put it in front. But either way is fine. Just bringing it up again. All right, again, scribble out f of x, call that y. We're going to switch x and y. Everything else stays where it is. Oh, I stuck a 5th root in this one. Not any different than a cube root. It just has a 5 instead. So nothing to worry about. All right, so getting the steps in the right order is like the biggest battle here. What do you move over first? Good, and we would multiply by 3. Good, so 3x equals all the rest of that. Just like doing a little puzzle. All right, then what? How would you get rid of a fifth root? Yeah, the fifth power. So take it to the fifth. So 3x to the fifth equals y plus 8. That would be 3x times 3x times 3x times 3x times 3x. Do you remember when we did binomial theorem and all that stuff to the fifth, and then we had the triangle? Yeah, all connected. All right, and then last step, subtract 8. Ooh, look at this next one. That's probably about as hard as I can make it. So switch x and y. X equals, ooh, 7th root to parenthesis y minus 9 over 6. There will be 4 steps for this one. What's first? Times 6. Good. Multiply the 6 over 6x equals all the rest of that mess. I'm not going to read it to you because that's just recopying what's there. Just try not to do a copy error. All right, and then, yeah, well, it is a 7th root, so we want to do like to the 7th. And again, if you want to distribute that too, you can. That's a totally valid way to get through the problem as well. But it's less work if you move it a different way. What's another way we could just get rid of the 2 entirely? Yeah, like just divide it over. But again, if you're like, well, I don't want to, Miss Colt, fine, you can distribute it. Like you'll work out, your answer might look a little bit different, but mathematically it'll mean the same thing. And then last step, just add 9. Perfect. And try to remember to write inverse. Are you guys feeling okay? This isn't bad, right? This is what your homework is, so like should go really quick. All right, and then last one, switch x and y. X equals 9 over 3 times y plus 4. And again, the problem is the y is in the denominator. So do exactly like we did with number 5. And we multiplied this over to the other side. We're going to take all of this and multiply it to the other side. I'm going to take the 3 and the y plus 4 and just bring it all over to the other side. So it'll be 3x times y plus 4 equals 9. Again, algebra is just moving stuff. I'm going to move this over here and move that over there. I would do the whole denominator. Now, in this problem, it just so happens that 9 does divide by 3. But what if it didn't? Like, what if this was a 7? Do you know what I'm saying? Like, pretend it doesn't divide, because what if it didn't? All right. Then what would you try to do to both sides? Remember, y is your goal. Yeah, divide by 3x. And again, I do realize 9 divided by 3 works out. But again, just like pretend it doesn't. Because again, what if it didn't? You would have to just leave it alone. So just pretend it doesn't. And then last step, oh, why did I leave those parentheses? I guess it doesn't matter if the parentheses are there, but we don't need them at that point. Last step would be minus the 4. So 9 over 3x minus 4. I'm going to say this on the recording so it ends up on here. Your homework is just 7 of these. And I'm collecting the work for it next time. Okay? Because it's just very basic, answer these questions.